Hey guys, I've been meaning to make this video for a week or so now, but if you've been following along at all with any of my streams over the course of that time, you'll know one of the things I've been working on is building a model context protocol server. And specifically, this protocol server is meant to talk to a third-party API. But one of the things I ran across while I was building this model context protocol server was I needed to be able to make a API request to this particular endpoint, which is basically allowing you to query records from this data store. However, this API requires your query or the rules around your query to be specified in this very specifically formatted filter string, basically. And you can do lots of things with this filter string. You can use all these different types of operators. You can also use and or operators to combine conditions together or rules together. You can also use a not operator to negate a particular rule. So your filter string can be pretty complex. And what I decided was that it was going to be kind of painful to try to prompt the LLM to basically create filter strings that look like this, right? Properly constructed, properly parsable strings that I could pass as part of my API request. And so I started to think about, okay, well, if I can't prompt the LLM, or if I don't want to prompt the LLM to build these strings, I need to have some way to communicate the proper structure of these filters through some sort of strongly typed object or through some proper data structure. And then I also need to be able to parse that data structure in my code into this filter string, so to speak, right? So I wanted to share this solution or this problem because it was one of the first times recently in a little while that my knowledge about data structures and algorithms really helped me solve this problem in what I felt was a pretty straightforward and easy to understand way. And so the first thing I had to think of was, what's the proper data structure to represent this filter? What's the proper way to represent this in a strongly typed way? And what I came up with was basically, this makes the most sense to translate that string into a tree, right? So basically, my root node of that tree is going to be whatever the top level rule or filter condition is. And then each of those nodes in my tree can potentially have branches or leaves that are either leaves themselves or they're branches to other nodes that I need to walk. And so in this case, you can see, right? So my root node's an and group, and that just has one single rule associated with it, but it also has an OR group associated with it. So it has a rule, and then it has an OR group, and then that OR group has a rule, and then it has a not group, and a not group can have a rule with it, right? And so you can kind of see I've got this tree structure to represent that filter string, but not only is it a tree structure, each node of that tree structure can be this polymorphic object that I need to figure out what type of node this is, and then handle that type of node as I'm traversing this tree. And then what this allows me to do, since I used a tree structure to represent this, is now what I can do is I can do not a breadth first search, but I can do a depth first search, or in this case, it's not really a search, it's more of just a depth first traversal to go through this tree and collect all the different field names and operators and values and build up that string that I showed you earlier, right? So now what we should be able to do is we should be able to have a way to say, okay, if the LLM generates this object, if the LLM generates this object here, then I can write code, or I can write a function that will parse that object into this string. And so that's what I'm going to walk through today in this video, and I'm just going to kind of speed run it for you. Now, granted, this took much longer than the 15 or so minutes it's going to take me to implement in this video, but I thought this was just a great example of how, if you know about data structures and you understand how you can use those data structures in different algorithms, that knowledge can actually be helpful to you to solve problems that you will encounter when you're building projects. Maybe not all the time, but when you need it, it's really valuable to have it. All right, so what will this look like in code? Let's go ahead and jump over into NeoVim here, and I have a small little test project set up here that I'm going to use to demo this and kind of show you it all working. And I should probably make this bigger because this is way too small for you to read. Let's go ahead and blow this up a little bit. There we go. And we're just going to step through how I went about kind of representing all this in code. So the first thing I want to do is I want to represent that polymorphic object, right? You can think of these as the nodes of my tree. And these nodes can take several different shapes. So let's just start with the base shape. So the first shape is a rule. And a rule obviously needs a type property because that's going to be how we identify the nodes from each other, right? When we're traversing the tree, we're going to use this type property to figure out what type of node is this. We're also going to need a AND group, right? So we're going to need an AND group here. And this is going to be type AND. And then we're going to need a type of OR group. And again, this is just making basically a discriminated union type, right? It's basically going to allow us to switch on this type property to figure out, okay, this is a node or this is a filter, but what specific type is it? So we can figure out how to handle it as we're traversing. We're also going to need a not group, right? Because the not group is going to have a little bit different shape than the others. And then we're going to also need a union type to represent this, and we're just going to call this filter in this case, and that's going to be a union of those 4 types. Now, each type has a little bit different shape, right? So the rule is kind of that primitive object. That's that final state that actually declares a particular condition or a particular rule. So status equals active, for example, right? And so this is going to have a few different properties. This is going to have a field name, which is always going to be a string. It's going to have an operator, which in this case is a string, but in my real world situation, this operator is actually an enum or a union type. There's only a certain set of operators that can be used. And then this is just going to be a value that's either a string or it's null, because there are some operators that don't require a value. They just, if you're checking if a field is empty or not empty, for example. And so then we're going to do the AND group. And so the AND group, right, is just an example of a list of conditions, right, that should be true in totality together, right? So that's just going to be a rules property that is of type filter, right? And that is important because the rules can be any of these other groups, right? And that's what allows us to create that tree structure where things can just become arbitrary complexity, and we can wire things together exactly how we need to express the logic we want to express through our query. And the same thing will be true for the OR group. We'll just have a rules filter. And then the not group is actually just going to be a single rule. You could support having the not operator negate multiple rules, but I'm just going to have it support a single rule for now. Okay, so now that we have this represented, let's go ahead and translate. Let's go ahead and go back to my Excalidraw diagram, and let's go ahead and translate this filter here to a structure in our code so that we can use it as kind of a test filter. So we'll say const test filter is going to be equal to a filter, and for now we'll just set that to an empty object, and let's just paste this right here so that we have a reference of what we're trying to do. Okay, so the root object, or the root node of our tree for this filter is actually going to be, oh, there you go, Copilot's kicking in to help us. There we go. Thank you, Copilot, right? And so you can kind of see, right, our root is the AND group, and then our AND group has one rule, but then our AND group also has a OR group associated with it. And that OR group has 2 rules. This rule and this rule. And so now the LLM, in the context of my model context protocol server, can now communicate to me or to my code, hey, I need to make a query of this shape. I need a filter of this shape. And that's much easier for the LLM to figure out with a very strong strongly typed structure than saying, hey, here's a bunch of examples of properly formatted query strings, and here's a bunch of different rules, and just doing that all in plain text. So now what I can say is, hey, LLM, give me this properly structured filter, and then I'll parse that into the string I need when I make my API call. This would also be very helpful outside the context of Model Context Protocol, but most developers, I think, would much rather build a filter with strong typing this way than have to pass in a query string like this. So I think this is an applicable solution to not just thinking about how you would build something that might be useful to an LLM, but also how it would be useful to a developer if this was for a SDK or some sort of API that you were going to expose through a library or a package that you were building and publishing. Next, what we need to do is now we need to implement the real, I guess, heart of the solution is we need to be able to take this and convert it into that string. So let's go ahead and declare a function called convert filter to string, and I'm going to scroll down here a little bit just so you can see what I'm doing a little bit better. Let's scroll down, and for now let's just throw new air, and then let's go ahead and give a test of this. So we'll say const result equals convert filter to string, and then we'll just console.log the result. All right, now we need to actually implement the convert filter to string logic. And this is where understanding algorithms, right? So we know what data structures are, right? That's how we were able to identify, hey, we could use a tree to represent this, right? Or this is my knowledge of data structures kicking in to help me figure out what's the best way to represent this data. But now that I know what data structure I'm dealing with, this is a tree, now I can start to think about how I would algorithmically process this tree structure. And I know typically when you're working with a tree, you can typically think of traversing it in a couple different ways. The two I always think of are depth first and breadth first search. The difference being with breadth first search, you're going to go wide first before you go deep, and depth first search being the opposite, where you're going to explore each branch of that tree all the way to conclusion before you do the next thing. And so in order to do that, in order to have this structure properly translated to this filter, I can't use breadth first search or my filter will get all out of whack. I need to do a depth first search so that I make sure and properly construct all the rules and add them all together to a complete filter string correctly. So let's go ahead and implement a depth first traversal of this tree. So the first thing you need to do whenever you're thinking of depth first traversal is you're gonna want to think of a stack, right? That's the data structure you're going to use to process over this tree. You could do this recursively, but I'm not a huge fan of doing things recursively, so I'm going to do this in much more of a imperative, a much more imperative way. So let me go ahead and disable Copilot so it doesn't steal all my glory. Copilot disable. And the first thing we're going to do is we're going to define what should be in our stack. So I'm going to have a type called stack item. And this is going to be one of two things. This is either going to be a string or this is going to be a filter. And you'll understand why it can possibly be a string in just a second. Okay, next we're going to initialize a stack. And we're using TypeScript here. So there's no special class or data structure or primitive type or complex type that comes along in TypeScript. So we're just going to use an array, and that array is going to be set to filter. But when we work with this stack array, we're going to treat it like a stack, right? We're going to push and then we're going to pop. So we're always remember the difference between a stack and something like a queue is stack is last item in becomes first item out, versus a queue, which is first item in becomes first item out, right? So that's the thing you want to kind of remember. And so when you're doing depth first traversal, you're going to use the stack construct. In other languages, they have built-in types, or I guess runtime provided types, or standard library provided types to do things like queue and stacks, but we're in TypeScript, so we're just using a plain old array. And then we're also going to need an array that keeps our result. So we'll say result. That's going to be an array of strings. And then we are just going to return that result really quick so we don't forget to do that. And all we're going to do is just join all those strings together. And let me scroll up again just so this is a little bit easier to see. And then we're going to need a while loop. And our while loop condition is just going to say, hey, as long as there's stuff on the stack, right? As long as that stack length is greater than 0, we want to keep iterating. And then inside our while loop, we want to get the first item in our stack. So we're going to say const current equals stack dot pop, because remember, pop is the method that removes the last element from an array and gives you that element back. So we're going to pop that item off the stack. It's also good to remember this. This is going to give you, again, going back to that first in, last in becomes first out idea. So when we push things on, we're going to pop that thing off, right? Now what we need to do is we need to check and see if there was actually a current, right? So it could be the array's empty, and so there's no item in the stack. And so say the stack's empty and we try to pop something off, then it's going to be undefined. And if it's undefined, well, then we know we've reached the end of our processing. We can just break out. You're probably also going to say, but you're already checking if the length is greater than 0 up here. So would you ever actually hit this? Probably not. But so that TypeScript doesn't complain later and I don't have to do a bunch of optional chaining, I'm just going to check for undefined and then break early. The next thing I want to do is I want to check to see if something is a string. So if the current item is of type of string, like this, then I want to continue, but before I continue, I want to push the current item onto the result. So I'll say result.push, and we're going to say result.push current, just like that. And this is why the stack can be a filter or a string, is because as we're processing through these nodes of our tree, as we're processing through the nodes and the leaves of our tree, we're going to slowly push on things onto the stack, like those parentheses, right? Or like the operators, the not, and, or operators that are just going to be strings. They're not going to be a properly constructed filter. They're just going to be a string. So whenever we encounter one of those strings, we just want to say, hey, put it onto the current and then move to the next item in the stack. All right, next we're going to now switch over our node's type, right? So this, you can think of this as our current node, and that's going to have a type field. And we have a few different cases we need to deal with. The first thing I'm going to do, though, is I'm going to say case rule, and then I'm going to say case not, and then I'm going to have case or. Right, we'll do an exhaustive list here. Case and then the default case will be we'll throw an error if we get to this point, right? We should never get to this point, but let's just say we do. We're gonna throw a new error, and we're gonna set that to unknown filter type, like that. All right, now we need to handle the rule. So the rule is pretty simple. All we're gonna do here is we're just gonna say, okay, if we've gotten to a rule, we're just gonna push onto our result a properly constructed string. In this case, it's going to be, excuse me, it's going to be the current field name, current.field name, and then it's going to be current dot operator, and then the last thing we need is current dot, current dot value, right? And we could also probably handle null. So let's say if current value is null, let's have a check here. We'll say if current.value equals null, then we would do result.push. It'd be very similar, but instead we're gonna say current dot field name, and it's just the operator we care about since the value is null, like that. And we want to break here, or we want to break here. And then the not is going to be a little bit different, right? Because the not is just saying, okay, what we want to do is we want to stack dot push the current dot rule, and then we want to stack dot push the current. We actually want to convert this to a string, and we should say current dot type and then a space. And remember, since we're working with a stack, we're gonna basically put things onto the we're gonna push things onto the stack in the reverse order that we actually want them to appear in that final string, right? So basically what I'm trying to do here with the not is I'm trying to represent something like not role equals admin. But if I pushed not onto the stack first, then we'd end up with role equals admin not, which is not what we want. So everything we push onto the stack is essentially in the reverse order of as we want it to appear in the final query string. So that's why the rule goes onto the stack first for processing or traversal, and then the not goes on second. Excuse me, I keep coughing. All right, now we'll do the most complex operation, the and or the or the and. So the first thing we need to do here is we need to push onto the stack the closing parentheses around the group. Then we need to process our rules. But again, our rules need to be processed in reverse order as they appear. Otherwise, we're going to end up with really weird results in our query string. So we're going to say const rules, and we're just going to make a copy of this node's rules, and we're going to reverse it. That way we don't mutate the original filter that was passed in. And then we're going to iterate over it. So we'll say for const index of rule, and then we'll say of rules.entries like this. And we need that index for a particular reason. I'll show you that in just a second. And then the final thing we're going to push on is we're going to say stack.push, and we're going to push that opening parentheses, right? This way, the parentheses this way are going to enclose all the rules that are going to be added to the stack here in this for loop. All right, so first thing we need, and the reason why we need this index is because if the index is not equal to 0, then we want to stack.push the type with space on either side. So we'll say current.type with a space on either side. And the reason we want to do that is so that we end up with rules that are separated by their particular combination operator, right? Or and. We don't want to put an and at the beginning or an and at the end. We only want to put that and when it actually is separating two or more rules. So let's go ahead and jump down here. And then if the index, if the index does not equal 0, we'll put the operator in there. Otherwise, we'll just put the rule. So we'll say stack.push rule, just like that. All right, and so with that depth first traversal, we should be at a point where now this console.log is going to print this string. And let's hope, you know how live coding goes. Let's hope I haven't made a fool out of myself. So we'll say right quit all, and then we'll just go ahead and build. Let me make this a little bit bigger so you can see. So npm run build. Great. And now we'll just run what was output, and we'll say dist index.js, and now we have an unknown filter type. And the reason why we have that is because Steven did forget to do something correctly. So if we go to index.ts, the reason why we're hitting this, right, is because I forgot to put a break statement here. So everything was falling through, or every or and group was falling through. Yes, even I make mistakes. I know, it's so crazy. All right, let's write this out again. We'll try one more time. npm run build, just node dist index.js, and there we go. So we have our ors in the right place, we have our nots in the right place, the ands are in the right place, and then we have our field names, our operators, and our values. And that looks just like we had in our Scala diagram. So this is what we wanted, and this is what we got. So again, I know this is a little bit contrived, obviously, because I've thought of this all ahead of time and I've already implemented it and thought through the problem, but I just wanted to illustrate how concrete knowledge of data structures and concrete knowledge of algorithms and how certain data structures can be used with certain algorithms can actually play a role in real solutions or real projects or real things that you encounter as you're developing, as you're writing code, as you're writing programming, because you see so much data structures and algorithms conversations around the areas of things like LeetCode or advent of code, these sort of what feel like contrived examples. But here's an actual real world problem I ran into where that knowledge came in handy. I hope you found this helpful. I hope maybe it encourages you to go out and try to further your knowledge and practice more data structure and algorithm things. Obviously, don't get lost in the weeds, right? I'm not a professional LeetCoder, but I thought this was helpful because it was one of the first times in a while where I thought, oh, great, here's where DSA can actually help me. If you did enjoy this, leave a comment or find me on Bluesky and let me know. If I screwed something up, or maybe you think there's an even better way I could approach this, obviously let me know as well, because I'm learning just like you are. All right, well, I hope you guys have a good rest of your day, and I'll see you in another video or another short or another live stream. All right, talk to you guys later. Bye.